So let's try to do a Poisson model. You would use a Poisson model when your outcome variable is of the type count. So for example, how many crimes someone has committed, or how many hours they spent doing something. So I've used some article for inspiration for an example here. It's called Maternal Behavior as a Predictor of Sibling Interactions During Meal Times. Once again, I've only very loosely based our example on this study. It's not in any way meant to reproduce anything from it, but it's interesting for you maybe to read it. So in our study, the objective is to examine the association between the behavior of mothers and siblings during mealtime. The predictors are the intensity of maternal engagement with the index child, so only one child in the family was selected to be part of the study, and this intensity of maternal engagement was with reference to two things: food-related or not food-related. The outcome variable was the number of encouragements from the index child to the sibling in terms of eating. The variable encourage, which refers to number of encouragements, is actually of type count, so how many, and therefore you have to tell M+ that this is a count variable. So you would simply say count is, and then you just say encourage. And then finally, if you do have missing data, you would have to tell M+ that you do. So therefore I would say missing are all that have a value of -99. So this is telling M+ that all the variables that have missing data will have it coded as -99. So if it sees this value on any variable, it should disregard it and treat it as missing. Then you might want to tell M+ what estimator to use. The default estimator is MLR. This goes in the analysis section. So you would say analysis estimator equals MLR. Next you would have to specify the model. So this goes under the model section. Take a moment to think about how you would specify this. Maybe jot it down on a piece of paper. Go ahead, I'll wait. Okay, so you want a regression path from food-related engagement to number of encouragements, and from non-food-related engagement to encouragements. So in this case, the outcome is encourage, and the predictors are food and non-food. And don't forget, for regression paths, you have to say outcome on predictor. So here we would say encourage on food and non-food. So now that you have your model, you will want to simply save it and press run. You now have the output file. Let's scroll down a little bit and see what it is that we've got here. So you see you have just one group of people. This is not a multiple group analysis. And you had 345 people in your sample. One dependent variable, which was of the type count, and two independent variables, food and non-food. And the estimator used was MLR. Let's scroll down a little bit more. You get this new section here, which says count proportions of 0, minimum, and maximum values. So now you see that 57.4% of the sample had a value of 0. The minimum value was 0, so that means no encouragements, and the maximum value was 50. So some kid gave their sibling 50 encouragements during the observation time. That's quite a lot. But half of the sample, in fact more than half, gave no encouragements to their siblings. Then you scroll down a bit more and you notice you don't actually have your usual model fit information criteria. You don't have a CFI and TLI and RMSEA. You do get the log likelihood value, and you also get the Akaike and Bayesian information criteria, which are useful in comparing against other models. When you use this to compare against other models, the model which has lower values of these is the better model. Then you will want to scroll down to see your actual results. So you will notice here that there's a significant relationship between intensity of engagement with the index child about food. So this is to say, when the mother engages with the index child regarding food-related things, this child will then encourage their sibling to eat more. And this is significant. But when the mother discusses other things or engages their index child with regard to other things, non-food related things, the index child will not necessarily encourage their sibling during mealtime, because this coefficient is not significant. So in this case, you would conclude that only the intensity of engagement with regard to food-related issues plays a role in how much a child encourages their sibling to eat during mealtime. This is it. However, you have now noticed that more than half of the sample that we had gave zero encouragement. This is a bit of a problem, and it's indicative that we might actually have a better fitting model and a more accurate model if we used a zero-inflated Poisson model. Now, the Poisson model is usually used when your outcome variable has a mean equal to its variance. But if it doesn't, a zero-inflated Poisson model can correct for that a little bit. And it's usually used, the zero-inflated Poisson, when quite a lot of people have zeros. By quite a lot, I mean something like 25% of the sample. However, this is just a guideline. So if you're in doubt, maybe you should try the other model and then compare the two. I'll show you how to do that in the next video.